Okay, so this video is on page 1 of the notes packet. I cannot emphasize enough to you how important this page is in this note packet. If you do not understand the principles behind this page, it might be a difficult unit for you. So please watch this multiple times if you need to. Come in and ask questions if you need to. The essential question that we are trying to answer in this unit is, why do atoms form bonds? So the key principle here is that atoms are most stable when their highest energy S and P orbitals are filled. Okay, so we're looking for stability here. There's something called the octet rule. Please note that I put an exclamation point here, emphasizing to you how important this rule is. This rule, every single thing that we do in this unit is predicated upon this rule. So I'm going to write out this rule and then talk to you about it, okay? So go ahead and fill this out, follow along with me if you need to. So this is called the octet rule. You should notice oct. You should be thinking about the number 8. Like octopus has 8 arms. Doc Ock in Spider-Man. Okay, octagon is 8 sides. So the octet rule basically tells us that atoms want to attain the electron configuration of a noble gas. So if you think about noble gases, outer shells, generally speaking, have kind of that happening there, S2P6. And what that means is that outer shell is full, and when it's full, it's stable. So you might hear any of your teachers, chemistry teachers, talking about being like a P6. Okay, what it's saying is, hey, these atoms are going to do whatever it takes to have an electron configuration that ends in that P6, because that P6 tells us that there's some stability happening here. So atoms are going to do whatever they can, just like I said. They can go steal electrons from other people. They can get rid of their electrons. And they can even share their electrons with other atoms in order to achieve that electron configuration of a noble gas. Okay, they want to have 8 valency electrons, hence the octet rule. This is because it brings them stability and low energy. Okay, so whatever they can do, they're going to do that makes the most sense, and we'll talk about the things that make sense as we go through this notes packet, but they're going to do whatever they can to get 8 valence electrons. Okay, so super important principle. I mentioned the word valence electrons in this video, and I'd like to really quickly touch on that. You should have learned this already, but if not, no worries, you're gonna learn it right now. So the question is, how do I know how many valence electrons are in an atom? It's a great question. Again, it's a very important question for this unit. So valency electrons are the electrons found in an atom's highest energy level. Okay? So again, it's that outermost energy level, that outermost ring in a Bohr model. Okay? So the cool trick is that the CAS group number, that's the ones that look like 1A, 2A, 3A. Okay, that number correlates to the number of valence electron for representative elements. So for example, carbon is right here in column 4A, so it has 4 valence electrons. This also technically works with the IUPAC system as well, right? 1, 2, blah, 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 13, 14, 15, 16, 17, if you just get rid of the 1. The point is, if it's in this column right here, it's going to have 3 valence electrons. This one 4, this one 5, 6, 7, 8. Okay, so that's how you find valence electrons. And again, really important, this octet rule right here. It is foundational to the rest of this unit.